A jar contains red and white marbles in the ratio 1 to 4. So I'm going to say that there are x red marbles and therefore 4x white marbles. So that's the actual amount. Therefore, if I replace 2 of the white marbles with 7 red marbles, then I'll have an extra 7. So suddenly I'll have x plus 7 red marbles. That's the actual amount. And then I'm going to lose 2 red marbles. So it'll be 4x minus 2. And then that is going to equal, so that is the actual amount. That's going to equal a simplified ratio 2 to 3. And I've created an equation involving ratios. Now I'm going to show you how we can deal with these. It's quite a hard topic, I think, but hopefully, my explanation will make sense, and you'll learn how to deal with these sorts of questions. They're quite fun, I think. But I just want to say again, this is the actual amount of marbles. That's what I'm allowed to sort, because normally with ratios, you can't add and subtract, but you can if you have the actual amount. And then we're writing it as a ratio and setting equal to the simplified ratio 2 to 3. So let's say we've got the ratio 4 to 2, which we could definitely simplify to 2 to 1. Now, what we see is that we're dividing by 2 to get from 4 to 2, and we're dividing by 2 to get from 2 to 1. And the scale factor actually comes from doing, say, the left-hand one of one side divided by the left-hand term of the other side. Or we could do it you could do the right hand, sorry, the left hand on the right divided by the left hand on the left. If you wanted to, you could write 2 over 4. But now if I do it consistently with the other two, I get 2 over 1. And what I'm trying to say is we can get the scale factor in this way by just dividing pairwise. 4 divided by 2 equals 2 divided by 1. Because I can do exactly the same over here. X plus 7, it's just a bit harder to visualize. X plus 7 divided by 2 will give me the scale factor, but that will equal 4x minus 2 over 3. And I've created a fractional equation. So I'm going to multiply through by the lowest common multiple of 2 and 3, which is in fact 6. I'm going to times the left-hand side by 6 and the right-hand side by 6. They cancel out, leaving me just a 3. This is in a bracket. Sorry, let me put it on the left actually. And then on the right, these two cancel out, leaving me 2. Another way to think about this is called cross multiplying. I basically times the right-hand side by 2, get rid of that 3, and times the left-hand side by 3 and get rid of the 2. But this is why it works. Now I'm going to expand the bracket. 3x plus 21 equals 8x minus 4. That means 5x equals 25. So x equals 5. Now we're not quite done. What was the ratio of the total number of marbles in the jar now to the total number in the jar before? So before we had 5x marbles, so we had 25 in total. And then we took away 2 and added 7, so we must have ended up with 30 over here. If you substitute 5 in, we'll get 12 and we'll get 18. So that means the ratio before to after, wait, what was it? Yeah, it was, oh, now, so sorry, got to make sure you get it the right way around. So now we have 30, so it's actually 30 to 25 rather than the other way around. And now we can actually divide through by 5 to give 6 to 5. That's our answer. Let me finally, I just want to substitute the x back into here to show you with the scale factor again. So if I put x in, I'll get 12 to 18 equals 2 to 3. And it's much easier this way to see that, hey, we're timesing by 6 and we're timesing by 6. But another way to get this scale factor is to do 12 divided by 2 equals 18 divided by 3. And that is exactly what I was doing over here. I just had it all in terms of x, so it was harder to see. But once I work out x and put it back in, you can see with numbers, it's just a little bit more intuitive to understand. But the key things about this question are writing down the actual number of marbles and then getting a ratio equation and then dividing, trying to understand why you're dividing and to create a fractional equation and solve from there.